Okay, Chapter 3, Basic Components and Technical Notation. And here on the introduction, circuit quantities and component values have extreme ranges in electronic circuits. It is not uncommon to have values such as, and here we have a very large frequency, 1,200,000,000 hertz, kind of a large number. Then here we have a number in farads, and it's 0.0000000047 farads in the same circuit, and these numbers are quite large. For this reason, metric prefixes and engineering notation are used to simplify communications and computations. And so in this particular value here, we would probably express this as, rather than this huge number, we'd probably say 1.2 gigahertz. And this one would probably be 470 picofarads. And these are much more manageable values than these giant numbers. Engineering notation is a technique for expressing very large and very small numbers in an easy to understand and interpret form. Engineering notation is based upon powers of 10, and examples of which are shown to the right. And so we have a few examples here. Remember, 10 to the 0 is always going to be equal to 1. And then we have powers of 10 or 10 to the 1, 10, 10 squared, 100, 10 cubed is 1,000. That's equivalent to 10 times 10 times 10. Going in the negative direction, if we have 10 to the minus 1, remember that's 1 over 10, equivalent to 1/10. 10 to the minus 2 is 1/100th. 10 to the minus 3rd, that would be 1,000th, the equivalent of 1 divided by 10 times 10 times 10. Okay, any number can be expressed as a series of digits multiplied by a power of 10. The procedure to express a number as a power of 10 is, and this is the procedure, these three steps here. Move the decimal point to any desired position while counting the numbers of positional changes. If the decimal point is moved to the left, the exponent will be positive. If to the right, the exponent will be negative. The value of the exponent will be the same as the number of positional changes made by the decimal point. And I want to look at the examples in 3.1. So let's convert the following numbers to equivalent numbers expressed in powers of 10 form. So we start out here, we have 5 values, and let's see, you don't usually do this, but we could say all of these numbers, you could say times 10 to the 0, because 10 to the 0 was 1, so any of these numbers times 1 is in fact itself. You don't usually do that, but we could say that. So let's take this first number and let's move the decimal place 1 point. So that would be 12.35, and since we moved the decimal point 1 place to the left, the exponent would be 1, a positive 1. If we had moved the decimal point, let's say 2 points, then it would have been 1.235 times 10 to the second power. And if we'd have moved it 3 places over to here, it had been 0.1235 times 10 to the third. And all of these are representative of the same value. Okay, here we have a decimal point, or a decimal. In this case, rather than going to the right, we're going to go to, or instead of going to the left, we will go to the right. So let's move this 1, 2, 3 points, so that we would say 4.2 times 10, and since we went to the right, it will be a negative exponent to the minus third. And if we, in fact, we could go over one more, and in that case we would say 42 times 10 to the minus fourth. And again, all of these would be equivalent. Another decimal, let's see, let's move this 2 places, so we'd say 2.26, and this would be, since we moved 2, times 10 to the minus 2. Here we have a large value, 78,200,000. We could move our decimal point 1, 2, 3, 4, 5, 6 places. How about that? 78.2 times 10, and since we moved 6 places to the left, positive 6. Then negative 2.77. If we move to the right 1 point, we could say minus 27.7 times 10, and since we moved to the right, 1 to the minus 1. We could have gone the other direction. We could have gone like this, and in that case we would have said minus 0.277 in this case times 10, and since we went to the left, the exponent would be a positive 1. So these are some alternative ways to express these basic numbers as powers of 10. Then in example 3.2, let's just do a couple of these. In this example, the number is given to us as a power of 10, and we're asked to convert it to a different power of 10. And the method, one method of doing this is to simply subtract the exponents, and that is how many decimal places you would move the current decimal place. So here we have 10 to the 4th, so we start out with the decimal, or the exponent of 4, and we're going to change, we want to convert from 2. So if we subtracted that, minus 2, we will have plus 2. So to convert this, we would simply need to move that exponent plus 2 places, so that would be to the left, 1, 2, and so that would be 1.44 times 10 to the 4th is equivalent to this value here. Then the second one, we have a negative 0.09 times 10 to the minus 1, and we want to convert that to times 10 to the minus 5. So let's start out with minus 5, and then we're going to subtract this exponent. It's going to be minus, in this case it's a minus 1. And so since a minus, that's going to effectively make this a plus. So the result would be a minus 4. So to convert this, we would need to move 4 places. So we'll go 1, 2, 3, 4. And it's still minus, so minus, but it's going to be 900. And we have that conversion. Engineering notation is similar to standard powers of 10 operations with restrictions. In engineering notation, the decimal point can be moved to any convenient position as long as the resulting exponent is either 0 or a multiple of 3. And so here you see some examples: minus 6, minus 3, 0, 3, 6, and 9 could be 12, 15, etc. Procedure goes like this. Write the number using powers of 10. Move the decimal point right or left while increasing or decreasing the exponent. The final exponent must be a 0 or divisible by 3. And here are some examples. In fact, you have sets of examples, 3, 3, 3, 4, 3, 5, and 3, 6. I want to do a couple or a few of the problems from each of these sections. The first one is to express 129 times 10 to the 5th in engineering notation. Now, since this is, the exponent is 5 here, this would be unacceptable in engineering notation. So we could either go to 3 or 6. 6 is the closest one, so let's go that way. So if we're going to increase, we have to go +1, and so that would mean we would have to move our decimal point 1 place. So we could say 12.9 times 10 to the 6th is the same as this value, but now that it's with this exponent of 6, it is now in engineering notation. Then they want you to use a calculator to here multiply 128 or 125.8 times 10 to the 3rd times 0.6. And I think I have a little calculator here. This particular calculator is available as a free download. It's called Calc 98. Let's just clear the screen here, and let's see the options here. Let's go to, actually I don't want options, I want, wait a minute, what do I want? Let's go to options again, and display. Currently we are in engineering mode. Let's go to normal mode and do this and just see what we would see as a normal calculation, and then we're going to change it to engineering. So we're going to say 125.8, 125.8, and then we want to go times 10 to the 3rd. So one way to do this would be just go down here to exponent and then 3, and then we're going to multiply that times 0.6. So we could go times 0.6 equals, and so there we see the result, 75,480. Now that is just in standard normal calculator value. Let's go to our options again, and now let's change that to engineering, and we'll leave it with 3 decimal places. And you'll see here the calculator has done it for us. The value 75.48 with exponent 3 is the resultant value. And then there's a number more in there. Please do those with your calculator. Okay, section 3.5. In 3.5 it says write using the nearest standard prefix, and you'll want to refer to table 3-2 when you do this. The first one is 120 times 10 to the 3rd volts. So we know that 10 to the 3rd is 1,000. We would typically write this as 120, and we would say k volts. Here we have 47 times 10 to the minus 12 farads. Now this is farads, has to do with capacitors, capacitance, and we would typically write that as 47, and minus 12 would be pico, and then we would say F for farads, or 47 picofarads. Then write using symbols in table 3-2. This comes from exercise 3-6, and let's see, so we're saying 125 times 10 to the minus 3rd. So the way we would typically write that would be 125 millivolts. Now that is equivalent to 0.125 volts. We would typically, though, in electronics, we would write that like this, 125 millivolts. Then we have 5 times 10 to the 3rd hertz. Remember, 10 to the 3rd is 1,000, so that would be a K. So we would say 5K and the HC for hertz. Then we have one down here, 0.001 times 10 to the minus 11th. And remember, minus 11th is not in scientific notation, so we want to change that to minus 12. We want to go one more negative, so we would need to move that decimal point one more to the right, so we'd move it over here to 0.01, and then we could make this to the 12th, so we could say 0.01, and that would be in a picofarad. Please do all of the problems that are in 3.3, 3.4, 3.5, and 3.6. Metric prefixes are used to communicate the values of very large and very small quantities. Most metric prefixes are used in place of powers of 10. Metric prefixes simplify the expression of numbers in electronic systems. And here we have powers of 10 and metric expressions. And as we go through this course, you're going to become very familiar with almost all of these. We probably won't use this one very much, the femto, which is minus 15. That's not commonly used in electronics, but all of the rest of these, from minus 12 to positive 12, you're going to get very familiar with. Now, centi actually falls out of the engineering notation because it's the minus 2. Minus 0 is just the number at whatever the number is. It's times minus 1, so that would, you don't typically see 10 to the 0, but it's understood that all values, unless they have one of the prefixes, is in 10 to the 0 notation. But we will use all of these: pico, nano, micro, milli, giga, mega, tera, etc. Okay, so in this lesson we've introduced scientific notation, looked at powers of 10. Let's just backtrack here. Powers of for units of measure. We did some calculations, and make sure you do all of these on your own. Engineering notation, we did some conversions from one power to another power, and then we expressed some values in alternative powers of 10, and we looked at what is scientific notation.